Welcome students to Unit 8 Notes, Section 12.5. This lesson is on circles in the coordinate plane. So we're switching from, arcs and chords and all that to actually finding out what they look like and how to calculate them within the two-dimensional coordinate plane. Now, if you want to try this warm-up on your own, feel free to pause right now. But I'm going to start explaining how to do these. So in number 1, 2, and 3, we have a coordinate plane with what could be, think about this, a radius of a circle. So, oh, hold on. My Apple Pencil disconnected. All right. There we go. We're back. So think about if we have a circle, right? Think about its radius could be represented as such, right? Doesn't that kind of look like a radius right here? So sometimes we're going to actually have to calculate this length, not knowing what it is right away to find how long the radius of a circle is. So I'm going to erase that. There's two ways to do this. If I see it on a graph, I could use the Pythagorean theorem. So for number 1, and only for number 1, I'll do both methods. So with the Pythagorean theorem here, we have 2, 4, 5. We have a length of 5. We have a length of 3. So I can do 5 squared plus 3 squared equals, in this case, the hypotenuse, which would be the radius. So h squared. Why don't I call it r for now, because we'll get more familiar with using r instead of h. So I will change this variable to an r. So 25 plus 9 equals r squared. So we have 34 equals r squared. So r is going to be equal to the square root of 34. And it wants this to the nearest tenth. Okay, so r approximately equals, I was going to say it's in simplest radical form at the moment. It's about 5.8 to the nearest tenth. So r equals about 5.8. That's one method of solving this using the Pythagorean theorem. So let me put all this information to the right. I think the more efficient way of doing this is going to be the distance formula, because you might not always have a graph like this one given to you. You might be given just an ordered pair and another ordered pair. So if 2 ordered pairs, you don't want to sketch this whole thing out to do the Pythagorean theorem. So you just want to jump into doing it using the distance formula. So let's remember or recall what the distance formula is. It's right here if you're wondering, right? So it's going to be the distance is equal to the square root of that. But let's just do it the way we remember it. We're going to call this negative 2, 1 and 3, 4. Oops. So we will have the distance formula as the square root of x2 minus x1 squared plus the difference of y2 and y1 squared. Yep, I'm going to run out of room for this one. There we go. Bear with me. I'm going to take my 2 ordered pairs. Again, it doesn't matter what direction you go in, as long as you're consistent. Negative 2, 1. There we go. So I'm going to do, how about negative 2 minus 3 squared plus negative 2 minus 3, and then 1 minus 4. Be careful. Don't just type this in your calculator. Be smart about this. Negative 5 squared is not negative 25, it's positive 25. So you just want to make sure you're getting always positive values. When you square this and this one, you'll always get positive. If you get a negative here, go back and do it again. So make sure you put it in parentheses in your calculator, or just always force it to be positive after you've done the squaring of it. So 25 and 9. So distance is equal to the square root of 34. So the distance is equal to, oh, we already have it, 5.8. So distance is approximately 5.8. So we get the same answer regardless if we use the Pythagorean theorem or the distance formula, because they're the same thing in terms of their result. Yeah. So we're just going to do this 2 more times. I'm not going to do the Pythagorean theorem. I am going to do the, let me label this. So, whoops. All right, but let's just do distance formula from here on out. Let me create some separation in the notes. Looks like this is negative. Oh, this is counting by twos. Be careful. Negative 2, 4, 6. Negative 2, 4, 6. Negative 6, positive 4. And this one is 2, 4, comma, negative 4. So if you counted by ones, you would obviously have gotten an incorrect answer. So distance equals the square root of, to save time, I won't rewrite the equation, but I'll do negative 6 minus 4 squared plus 4 minus negative 4 squared. Remember, I'm going from negative 6 to negative to 4, so negative 6 minus 4. So you got to go back here, 4 minus negative 4. So distance equals the square root of negative 10 squared plus 8 squared. Distance equals the square root of 100 plus 64. So it looks like it's going to be square root of 164. Which is approximately to the nearest tenth, 12.8. All right, this last one. We got 0, comma 2. It's counting by ones again. And then negative 3, comma negative 3. Oops. All right. So distance equals the square root of 0 minus negative 3 squared plus 2 minus negative 3 squared. Distance equal to the square root of 3 squared plus 5 squared. Distance equals square root of 9 plus 25. Distance equals the square root of 34. Let me make sure I did that right. 1, 2, 3, 4, 2, 4, 5 by 3. This one's also a 5 by 3, just like the first one. So I get the same result as 5.8. So distance is approximately equal to 5.8. All right. So you're going to need to be able to have that skill and use that skill, because when writing equations, sometimes they're going to be written out quite easily for you, and you're quickly going to be able to write the equation of a circle. However, sometimes you're going to have to do the distance formula to find the length of a radius. So when you write an equation of a circle in standard form, the standard form has to do with the distance formula. Why? Think about the distance formula. If I were to take this right here, this radius, and I know its distance, I know how long it is, and I rotate it around a circle, it will always be equidistant from the center. That means that the distance will always work out. So what we have is a collection of x's and y's that forever around this circle, no matter what x is, as x changes, y changes too, right? What stays consistent is h and k. H and k being the center, so center is h and k, where x and y could be any two variables that they want it to be, any two numbers that those variables want to be, as long as they work together to make sure that this distance stays the same as it rotates. Now, knowing that, it comes exactly from the distance formula. So the distance formula being distance equals x2 minus x1 squared plus y2 minus y1 squared now gets replaced with something consistent, h and k, never changing. X and y always changing to make sure that they balance themselves, but they always have to be equivalent to the length of a radius. So from that, if you square everything to get rid of this radical, you notice that you get r squared on this left-hand side. Well, that is exactly the same thing as the Pythagorean theorem. L squared, call this L, call that leg 1. How far apart are h and x? And then call this one L2, how far apart are y and k? And you get the hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. All we need to know is how far apart these are. But we really don't. We're going to use the center h and k, and r being the radius, to answer all of these questions. So the equation, the standard equation, this is standard equation of a circle, is what you see in this box. X minus h squared plus y minus k squared equals r squared. Notice that you're taking h away and you're taking k away. So if your center, for instance, is 5, 2, it's going to look weird, but it's okay. It's going to be x minus 5 and then y minus 2. Because if you were to cover this idea up here, if you cover that part up, h itself is just going to get replaced by that number. So here, let's do a couple, let's see what examples we have. Oh, yep, there we go. Standard form of the equation was listed right below that. Okay, write the standard equation for a circle with center 5, -2, and radius 7. Well, here's my h. Oops, I didn't like that. Did he erase something prior? No, okay. I'll put that back. Here's my h, here's my k, and here's my r. Okay, make sure it's radius. If it says radius squared, you have to find the radius by finding the square root, but all our numbers are there. So the equation is x minus h squared plus y minus k squared equals r squared. Well, it's going to be x minus 5 squared plus y minus -2. Notice what I did, I changed it to a positive. You can either rewrite it as negative, but two negatives will be a positive, equals 7 squared. And so the final answer, we always want to square, we don't want to leave it, we don't want to leave it as 7 squared, we were going to rewrite it as 49. So when you see this, you immediately should know that the radius is not 49, but the radius is 7, because 7 squared is 49. So if you were given this and asked what the equation of a circle, if you were asked what the center was, you're just going to do opposite of what you see. So if you see a -5, right, you see a negative 5, if you see a negative 5, h was a positive 5. If you see a negative 2, k was a positive 2, k was a negative 2. If you see 49, r was really 7 because the square root of that. So you're just going to flip-flop between the orders. All right. We're going to do a lot more practice, so you'll be masters at this very soon. Let's do another one. Write the standard equation of each circle. It's going to be, remember, it's x minus h squared plus y minus k squared equals r squared. Okay, so I'm going to do, let's see, I would do x minus 3 squared plus y minus 5 squared equals 36, because I want to square my r, and I am done. That's it. Okay. So now this one's a little bit tricky, but we'll get through it. X minus a negative 2 is going to be x plus 2. And then y minus k is going to be y minus negative 1, which is y plus 1. And then r squared, so it's the square root of 2 squared. Don't freak out. 2 times 2 is 4, so it's the square root of 4, which is 2. Squaring a square root, they're inverse operations. They're actually going to just clear the way. So you can either write it like this now, right, and then go one more step, or you can go immediately to this new step. So you can skip step 3 that I wrote there. You don't have to do that. Okay. If you want to check if you got it right, well, the square root of 2 is what the radius would have been, so because the equation, remember, is r squared. So going back, finding square root, you got it right there. Yeah, so that's that. Okay, again, you can skip. You don't need this step right here, number 3, but you can do it if you would like to. All right. Write the standard equation of a circle with center 1, negative 3 that passes through the point. They don't give me a radius, so what is my radius? I don't know what my radius is. So I need to find my radius, right? That's step 1. I already know my center, so here's my h and here's my k. Let me label them prior. H and k. Whoops. These are my h and k and my r. This was my h. That was my k. That was my r. All right. I just want to be consistent. So here's my h and k. What I don't know is what my r is. So all you have to do first is the distance formula to find your r, because you want to know how far apart these items are right here. You don't know, but you can find out your radius. And what's cool about this is that you actually you'll actually solve for radius squared, and you don't have to go back and find the square root of it because you'll just be squaring it again. But here, let me show you how to do this one. So you're going to use these 2 points, 1, negative 3, and 2, 2. You're going to do distance equals the square root of this. So 1 minus 2 squared plus negative 3 minus 2 squared. Distance equal the square root of negative 1 squared plus negative 5 squared. Distance equals the square root of 1 plus 25. Distance equals the square root of 26. So that's your radius. That's how long that is. So the square root of 26. but when you write your equation, you want to make sure that you're going to do x, let's see, yep, there we go. So you're going to do x minus 1 squared plus y minus negative 3, y minus negative 3, which is y plus 3 squared equals r squared. Well, I'm sorry, r squared, which is the square root of 26 squared. So x minus 1 squared plus y plus 3 squared equals 26 total. Good. And that's the equation of the circle. Now, last year, I've always taught the equation of a circle that way, when you don't have your radius. Last year, a student asked me a question, and I was like, no, you can't. No, I don't. Wait, what? What are you asking? I was a little bit confused. And then finally, I knew what they were saying. They were saying, Mr. Abernathy, do I have to do the distance formula, right? Do I have to do this distance formula if I know what x and y are and what h and k are? So what the student noticed is that there's another way to do this. So if this is easier, feel free to do this one too. There's your x and y. So this student said, if I know h and k and I know x and y, here, let me change the color of this, just so that you don't mix up the two. If you knew x and y, here's version 2. Here's what I can do for version 2. So they were like, if I just do x minus h squared plus y minus k squared, I'll get r squared. So they said, let me just put in all my numbers and then I'm done. And I was like, that's actually much easier than doing the distance formula. So they did 2 minus 1 squared plus 2 minus negative 3, which is 2 plus 3 squared. And they immediately solve for r squared. So this is a version 2, or the second type of way to do this. So 3 squared plus 5 squared equals r squared. Oh, sorry, 1, not 3. 1 squared plus 5 squared. So r squared equals 26. And that is what they immediately put in for r squared. I thought it was really cool. So these are two different ways to solve this same problem, using either the distance formula or version 2 using the actual equation of your circle to solve for r squared. And once you have r squared, you're good to go. The radius would be just the square root of that. It might save some time, but it's another way for you to check. So let's try that version 2. So let's do version 2, knowing that we have our, for instance, our point here, x and y, and our h and k. So we're going to do -1 minus 2. You have to be careful. Make sure you go in the right order. This is your center, not this one. So the center is your h and k. So it has to go in that order. You can't pick and choose for this, which h's and which, well, I would just stick with the order. So there you go. Plus y, which is 1, minus k, which is 3, equals r squared. So -3 squared plus -2 squared equals r squared. 9 plus 4 equals r squared. 13 equals r squared. You don't need to do anything else. You have your r squared already. So from here, we will do the equation again. And we are going to say x minus 2 squared plus y minus 3 squared equals r squared, which we already found was 13. Now you have the equation of that circle. All right. So here's a few more problems. Notice these count by 2. Be careful, your units count by 2. So first thing I want to do maybe is find my radiuses. I'm going to do, this is a length of 2, 4, 6, 8, 10. R equals 10 for that one. Your center is at 4, 20. For A, we have a center of 16, 10 with a radius of 2, 4, 6, 8, 10 as well. And for O, looks like it's at 0, 0. That one's easy. And we're going to say a radius of 12. R equals 12. Let me make this line a little bit thicker so that you can see it. There we go. So we have 12. We have, 10 and that. So circle O is going to be written as x minus 0 squared plus y minus 0 squared equals radius squared, so it's going to be 144. What's cool is that when you have that, you can simplify that one. You don't need to say the zeros, so you can just say x squared plus y squared equals 144, and that is actually in standard form. It's actually a little bit more simple standard form. Then circle A, we're going to do, circle A is x minus 16 squared plus y minus 10 squared equals 100. 10 squared is 100. And then circle B is, sorry about that, x minus 4 squared plus y minus 20 squared equals 100. Again, that one had a radius of 10, so radius squared is 100. I think that's it for that problem. In the textbook, it was talking about triangulating cell towers. So like if you were driving and you were between 3 cell towers, where, which one would you be connected to, or which one would be the best for coverage, blah, blah, blah. But here I just wanted you to focus on the circles. All right, the next one, find the center and radius of the given circles, then graph each. So remember, go in the reverse order for these. So in this case, your center is going to be 7, negative 2, because we see a positive 7, right? So that's your H. H is 7. But remember, this is y minus negative 2. Negative 2, right? Y minus negative 2 is y plus 2. So in this case, that is your K. So you're just going in reverse order. If you see a negative, you make it a positive to go backwards to your center. And then, if you see a negative, you go positive, and positive, you go negative. And then your radius is the square root of 64, so that's going to be 8. It's going to be 7, negative 2 with a radius of 8. What I'm going to do is, let me do this one first, and then I'll graph it. So this one is 2, 3, and so that's your H, that's your K, and then radius is 10. For both of these, I'm going to count by 2's because I think I'll be able to fit a radius of 10 because that will really go 5 units. Well, 5 blocks, right? So 2 comma 3, so 2, 4, 6, 8, 10, 12, 14, 2, 4, 6, 8, 10, 12, 14, -2, -4. I'm just going to label these. Hopefully it's enough. We'll see. If not, we'll do our best to fit this on here. And I love copy paste. All right, I'm going to just copy this over to my other one. Oops. Yep. Good enough. All right, so this is 2 comma 3 with a radius of 10. So 2 comma 3 with a radius of 10 is going to be 2, 4, 6, 8, 10 right there because I'm counting by 2's. Now what I did notice in the past is this is not the best grid because a grid is not perfectly set up. So we're going to do our best. If it went to 12, it went to -8. We're going to say it's about looking like that. It's not going to be perfect because this grid, it doesn't look it, but these grids aren't perfectly square. So it's a little bit stretched. You see how the 14 doesn't reach up here? It should really reach up to, oh no, 13. Yeah, it's off by maybe a quarter or so. All right. Now this one, this is 7, -2. 7, -2. 7, -2 is right there with a radius of 8. Now that one will work. So 2, 4, 6, 8. And then we have our circle. We have about that. It's reasonable. All right, so there you go. You have your, we can label it 7, comma, -2 with a radius equals 8. This one will do 2, comma 3, the radius of 10. Okay, looks like we got to the notes. So this is where I'm going to end the video, I think, to keep it short. You can always ask questions in the Google Meet. Looking at this, looks pretty good. I think you can do all those questions. You got some graphing, and yeah. Don't forget to do both that and the worksheet that goes along with it. Do your best. I know these are kind of hard to read. They count by 5 sometimes or 2's, but yeah, do your best on those. Again, the answer key is all online. Here's one. 1/2. When you square, don't forget r squared is going to be 1/2 squared. That's 1 times 1 is 1. 2 times 2 is 4. So r squared is 1/4 for that one. Okay. Yeah, you should be good on these. All right. And so I'll leave you with that and have fun. Good luck.